Okay, let us continue. And we continue with ordinary level chemistry. We are still moving with the mole concept. And as I told you that what we have covered so far, remember we have looked at what we call the mole. Then we looked at relative atomic mass. And we saw examples of relative atomic masses with no units, just values. Then we looked at relative formula and relative molecular masses of compounds for the ionic and covalent compounds respectively. Now, we looked at the calculation of relative formula and molecular masses using the valencies, using the relative atomic masses of the elements in that compound given. So, you need not forget that because I told you that this thing moves just in some kind of a chain. What you learn at a particular point, you learn it at the next point, you use it at the next point for learning the new concept that comes in. So we are going to apply what we have already learned at a later stage, even right now. So let us look at what we call percentage composition by mass of substances in compounds. So we are going to look at the percentage of different substances. Can be elements, can be a group of compounds, can be say like moles of water crystallization in compounds. So when we are doing this, we shall make sure that the mass of that compound, percentage composition, will be equal to the mass of the substance. And I said the substance can be either an element or it can even be, in this case, water of crystallization out of the relative, or we can say out of the mass of 1 mole of the compound. And to make it be a percentage, we shall multiply by 100. So this one gives us what we call percentage composition, and we shall make the unit be percent because it is a percent in this case. So let us look at how to get the percentage composition by mass of some substances in their different compounds. So let us start with it. 1, the percentage of oxygen in water. Given that hydrogen has a relative atomic mass of 1, oxygen has a relative atomic mass of 16. Now let us say this. In order for us to get the percentage of oxygen, we should get to know the mass of oxygen in this compound, and we should also be able to know the formula mass of water in this case. So we shall apply the other expression to get the percentage of oxygen. Now let us get the mass of 1 mole of water. So we are going to use the formula of water. We are now applying the use of valencies to get the correct formula of the compound. And we shall say mass of 1 mole of water will be equal to the sum of these relative atomic masses here. So for hydrogen it will be 1 times 2. Then for oxygen it will be only 1 atom of oxygen, which is having a relative atomic mass of 16. So this one gives us a total of 2 plus 16, giving us what? 18. So this one is the relative molecular mass of water. Now, let's go now to the percentage of oxygen in water, we say that it is going to be the mass of that substance out of the total mass of 1 mole of that compound, and we multiply by 100. So oxygen is having 1 atom only in water, and oxygen, the relative atomic mass is 16. So for oxygen it is 16 out of the total mass of this compound, which is 18 grams, and the relative formula mass is 18. So it will be over 18, and we multiply by 100. For the sake of simplicity, pick your calculator and we get this. So it will be 16 over 18, and we multiply by 100. So our answer in this case from my calculator is it is giving me a total of 88.8888889%. This is the most correct answer. In most cases, we tend to round off right from the calculator. The calculator has given you a value. For you are writing something else. First write the whole of it, and if there be need for rounding off, it comes later on and becomes an approximate value. So it is approximately, suppose you wanted to round it off to 2 decimal places, then it will be approximately 88.89%. So that one is the percentage of oxygen in water. That's the percentage composition by mass of oxygen. We have dealt with the mass of oxygen. So this is how we have done it. Let us look at another example. Let's see the percentage of sulfur in aluminium sulfate. Given that aluminium has a relative atomic mass of 27, sulfur with a relative atomic mass of 32, and oxygen with a relative atomic mass of 16. Let's get this, starting with the formula of aluminium sulfate. Aluminium sulfate, the valency of aluminium is 3, and we are supposed to put it down here. So we have to put the whole of sulfate in a bracket and put the 3, which is the valency of aluminium, here. And then sulfate has got a valency of 2, as we had seen earlier. So we cannot in any way bracket aluminium because there is only 1 atom of aluminium. So we put the 2 here, and this is the formula of aluminium sulfate. Let us get now the mass of 1 mole of aluminium sulfate using the relative atomic masses of the component elements in aluminium sulfate. So there are 2 atoms of aluminium. It will be 27 times 2 plus, then sulfur, we have 3 atoms of sulfur. It will be 32 times 3 plus oxygen. We have these 4 atoms plus the 3 outside here. It will be 16 times 4 times 3. So let us try to get this. 27 times 2 gives us 54 plus 32 times 3 gives us 96 plus 16 times 4 times 3, giving us a total of 192. Now let us sum them up to be 54 plus 96 plus 192. It gives us a total of 342. This is the mass of 1 mole of aluminium sulfate, or in this case it is the relative formula mass because it has got no unit. So let us look at the percentage of sulfur. Percentage of sulfur in this case will be equal to the mass of sulfur. There are 3 atoms of sulfur and it is here. So it will be 32 times 3. We divide it by the total mass of aluminum sulfate of 1 mole of aluminum sulfate, which is 342, and we multiply by 100. So let us get it. 96 times 100, and we divide by 342. So we get a total, we get a value of 28.0701754%. This is our correct answer, the real answer which we have got from the calculator, and we can now make it an approximate value if we want to round off, say to 2 decimal places. If we want, it becomes, say, 28.07%. Please never you forget the unit in this case. So the unit is percent. Remember, we are calculating percentage composition. Let us look at our final example on percentage composition. This time let us deal with a hydrated compound. I want us to deal with any hydrated compound. So we are going to look at the percentage of water crystallization in a hydrated compound. Let us look at the percentage of water of crystallization in sodium carbonate 10 water, a decahydrate with 10 moles of water crystallization, given that sodium has got a relative atomic mass of 23, carbon with a relative atomic mass of 12, oxygen with 16, and hydrogen with a relative atomic mass of 1. Let us calculate the percentage of water crystallization. And what do we do first? We first write the formula of the compound. This is sodium carbonate, and we have seen that the valency of sodium is 1, the valency of carbonate is 2, meaning that these 2 will come down here, and it is carrying 10 moles of water crystallization. Dot 10 water. So let us get the formula, the relative formula mass of sodium carbonate 10 water, which is 23 times 2. We are done with sodium, we go to carbon, only 1 atom, that's 12, plus we go to oxygen, 3 atoms, that is 16 times 3. Then we are going to add to the whole of the 10 moles of water crystallization, that is water, 10 of them. So it will be 10 times the whole mass of water, that is 1 times 2 plus 16. And this one gives us 46 plus 12 plus 16 times 3, which is 48, plus this is 2 times 16, which is plus 16, which is 18 times 10, which is 180. So 46 plus 12 is 58. 58 plus 48 is 106. 106 plus 180 will give us 286. This one is the relative formula mass of sodium carbonate 10 water. Now let us get the percentage very fast. Percentage of water of crystallization. The percentage of water crystallization will be the mass of water, and we have found that it is 180 over the 286, which is the total mass, and we multiply by 100. And what do we get in this case? We shall have 180 times 100, and we divide by 286. And we have got 62.8 93706.94%. And then this is the correct answer. You write the whole of it. And finally, you can get the approximate value when you round off to say 2 decimal places as we have been doing. This one gives us approximately 62.94%. So this is how we can work out percentage composition by mass of different substances in compounds. And next, we are going to look at some few numbers that you will try at your own free time. So thank you for watching.